In this video, I will introduce some vocabulary to help us begin to understand and describe polynomials, and then in future videos, we'll talk about operations with polynomials. So before I talk about polynomials, let me define a monomial. A monomial is a single algebraic term made up of a number, a variable, or a product of numbers and variables. So a single constant term, like the number 3, could be a monomial. More often, you'll have a variable. X squared could be a monomial, or you could have a product of numbers and variables. So I could have 2x squared y. This is another example of a monomial. There's no addition and subtraction here, just multiplication, and that makes a single term. The degree of a monomial is the sum of the exponents of its variables. So this monomial has degree 0. There's no variable part with an exponent. This monomial has degree 2. This monomial has degree 3 because I have x squared and I have y to the first. So if I add those exponents, that's a sum of 3. Now that we know what a monomial is, we just combine monomials through addition or subtraction to create polynomials. The degree of a polynomial is the highest degree of any of its terms. So here's a couple examples of polynomials. 7x to the 4th minus 3x cubed plus 2x minus 5. 5x minus 4x to the 4th plus 3. These are just two specific examples of polynomials. They have these monomial terms, right? And each of the terms are combined through addition or subtraction. We often classify polynomials by the number of terms that they have. So if it's a single term, that's a monomial, right? If it's 2 terms, that's a binomial. If it's 3 terms, that's a trinomial, and so on. The degree of a polynomial is the highest degree of any of its terms. So as I look at this polynomial, the highest degree of any of its terms is degree 4. So I would say this polynomial has degree 4. The same with this polynomial. Even though this one is written out of order, this has degree 4 because that's the highest degree of one of its monomial terms. Now we typically write polynomials in descending order. So the correct way to write this one, or the traditional way to write this one, would be to rearrange the terms here. We would write negative 4x to the 4th first, and we would say plus 5x plus 3. We write these variables, or these exponents, in descending order. 2 more definitions, properties that we want to note of polynomials. The leading coefficient of a polynomial is the coefficient of the term with largest degree. So remember, this one has degree 4. Its coefficient is 7, so that's the leading coefficient of this polynomial, 7. The leading coefficient of this polynomial is negative 4. Remember, before I arranged this one in descending order, that negative 4 was not the first number in the polynomial. The polynomial has to be arranged in descending order, and then you can say the leading coefficient is the first number. That might not always be the case. Your polynomial might be out of order, and you have to arrange it first. Finally, the constant term is the term without a variable. That's the number part, right? So here, the constant term of this polynomial is negative 5. Here, the constant term of this polynomial is positive 3. Polynomials in a single variable are functions. And so here I have a polynomial written in function notation. P of x is x cubed minus 3x squared minus 4x plus 4. The degree of this polynomial is 3. That's the highest degree of any of its terms. The leading coefficient is 1 because the coefficient along with x cubed is 1x cubed, right? So leading coefficient is 1. The constant term is 4. That's the term with no variable. We're going to evaluate p of negative 3 just by inputting the number negative 3 into the function. Let's find the output. So p of negative 3 equals negative 3 cubed minus 3 times negative 3 squared minus 4 times negative 3 plus 4. Evaluating each of those terms, we get negative 27 minus 3 times 9. Negative 3 squared is positive 9. Minus 4 times negative 3, that works out to plus 12 plus 4. I'll rewrite that one more time. Negative 27 minus 27 plus 12 plus 4. And when we combine those terms, we get a result of negative 38. So we evaluated this polynomial function just like we evaluate any other function. We input negative 3, substitute it for x, and simplify. Our output is negative 38.